Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to find the linearization of a function at a given point. So what we're going to do here, what is L of x at x equals a? So L of x is the linear approximation of this function. A is going to be 0 in this example. So what we're going to do is try to find the linear approximation of this function, square root x plus 1 plus sine x, right around x equals 0. Now, a rough sketch of the function would, I think be kind of beneficial. For starters, this thing right here is only defined for values to the right of -1. So, and this function increases to the right. So this thing's probably looking, something like this. It's probably got some wiggle due to that sine part. The exact picture here is not super important for this discussion, but roughly speaking, this function probably looks something like this. All right, it is defined at x equals 0. It goes through the point, if I put a 0 here, this is going to be a 1, and sine of 0 is 0. So this thing goes through the point 0, 1. I'm going to go ahead and actually sketch the tangent line at that point. And I like to put my tangent lines in red for some reason, I don't know why. So there's the tangent line, and again, this tangent line can be written in the form y equals mx plus b, and this is what we're looking for. This is the linear approximation of this function right in this region. And again, if you look kind of in this region right here, and I kind of blow that picture up, I'm going to move this over here. We've got the tangent line, and then we've got that function coming in there. It might be doing something like this. And again, the idea here is as long as we stay right around 0, the function in the tangent line, the function is approximately linear. It may not look like it in my picture, but imagine blowing it a little more. Imagine taking this and blowing it up a little bit more. The tangent line will be straight. The function will be right next to it. So that's the idea. Stay real close to 0, and then the function and the tangent line are basically the same thing. So in order to find the tangent line, we're going to need the slope. So here we have a function. I'm going to go ahead and calculate dy dx. Now, as we differentiate this function, this guy has a derivative of 1/2 times x plus 1 to the minus 1/2. Now you have to chain rule this. Think about the inside of this thing. The derivative of the inside of this is just 1, so I'm going to stop it. Had this been maybe an x squared in here, you would have a times 2x here, but this guy right here, the derivative of sine x is cosine x. Now what I'm just going to do is evaluate this at x equals 0. So this is going to be, at x equals 0, this is going to be 1 over 2 times 0 plus 1 square rooted, or to the 1/2. The minus sign puts this thing downstairs, plus the cosine of 0, which is 1. And 0 plus 1 to the 1/2 is 1. So this is 1/2 plus 1. This is 3/2. So our line here, our tangent line, or our linearization, must look something like this. Y equals 3/2 x plus b. Now, both the linearization and this function go through this point. And again, this was the point 0, 1, so that we know when x is 0, y must be 1. We can solve that for b, and we get b equals 1. So y equals 3/2 x plus 1 is the equation for the tangent line at that point, or in other words, that's the linearization of this function at this point. So I hope this video helps demonstrate how to linearize a function around a point. Have a great day.